everyone. I'm Anis Fatima. I'm a PhD student at IIIT Hyderabad, India, and I'm going to present my research paper titled Polypyrrole-based cotton flexible pressure sensor using in situ chemical oxidative polymerization. So in today's era, the emergence of Internet of Things and the increase in the use of smart devices, smartphones, smartwatches, Alexas have been possible only because of the evolution and development of sensing systems, and more specifically, the flexible and variable sensors. Furthermore, as we are moving more towards the sustainable and environmental friendly electronics, there have been development of sensors using organic and biodegradable polymers. So polymer-based sensors that show flexibility and stretchability have been in great demand and recognition for sensing applications. So we have made one such organic conducting polymer, polypyrrole. So I have made a pressure sensor using polypyrrole, which is extensively explored because of its ease of preparation, high conductivity, biocompatibility, good environmental stability, and its non-toxicity at low concentrations. So we have synthesized polypyrrole using liquid chemical oxidative polymerization of pyrrole monomer on cotton fiber. So we have washed the cotton pad using the distilled water, dried it at 60 degrees centigrade, prepared different concentrations of pyrrole and FeCl3, and we have to see that at which concentration we can get the highest conductivity. So we have achieved highest conductivity at 0.4 molar of pyrrole and 0.8 molar of FeCl3. So we put the cotton pad in pyrrole for like 5 minutes and then we remove it. Then we put it in the FeCl3 for 1 hour at room temperature, and then we remove it from FeCl3 after an hour, wash it with distilled water to remove any unreacted FeCl3, and then again dry it at 60 degrees centigrade, and your polypyrrole coated polypyrrole coated cotton pad is ready. So after preparation of this of the polypyrrole, we have also like tested the measurements and everything. So the SEM images show that there have been uniform polymerization on the cotton strands, and the absorption achieved were also in the typical range of pyrrole and polypyrrole. So we have designed a sensor using the cotton PCC, polypyrrole coated cotton, by sandwiching it between the two copper electrodes, and then we connected it to a bias resistor, which is 1 kilo ohms, and we read the data from the microcontroller by applying pressure on it and characterized it to see how the resistance is changing on applying the pressure. So we have achieved a good range of pressure from output from 16 pascals to 160 kilopascals, and we have also tested the repeatability of the sensor, which is very important for using it in commercial applications, and we have received the response time of the sensor at average of 463 milliseconds. The sensor response was also evaluated for compressive strain. So to apply strain, we have put the sensor in between the screw gauge, and the initial length was 25 mm, and as we were increasing the length, the resistance decreased from 1.8 kilo ohms to 1.2 kilo ohms, and the gauge factor of the sensor was achieved as 0.32. It can be used in various applications like supercapacitors, nano coatings, and biomedical applications and sensors. So I have used this in my project in making a 4x4 pressure sensor matrix to to determine at what point how much pressure can be applied. That's it. Thank you so much.